Hi kids, we will be going into this paper discussion. You can look at the first question. Water which wets the wall of vertical capillary tube rises to a height h within it. So, if there was only tube, it would have risen to height h. And there were four different scenarios given. Then they were asking what is the shape, right? Shape of the meniscus. Now, if there was only beaker and this tube, it would have raised, water would have raised to a height h, where if this pressure difference will be 2T by R. So, this is rho GH will be equals to 2T by R cos 0 or whatever, right? Or I can say this surface tension force can handle a height of h. This surface tension force can handle a height of h, that is the meaning. Now, you are breaking it somewhere here, so liquid can flow, but the thing is liquid can't flow here because this is above this level. If liquid flows, then it will be like you will be getting unlimited energy, so that won't be happening. And you should understand the pressure here is P naught, the pressure here will be less than P naught, the pressure here and here will be same, which is less than P naught. Pressure outside is P naught, pressure inside is less than P naught. So, it is going to take some shape like this, Now, here this pressure and this pressure are P naught, inside pressure and outside pressure were P naught. So, it will be flat. In the same way here, and this surface tension force can handle this weight easily, but this weight is more than whatever it can handle. So, what happens here is surface tension force will be balancing this much weight of water. It can balance, but it can't be balancing, so it will be flowing out. So, that is how you will be guessing the shapes, and in fact, the same explanation I am going to attach in the PDF. You can read by yourself. So, there were different scenarios, and when you push them, they are going to perform SHM. You need to calculate what is the time period. So, you can easily get the relation between density of the body and density of this by making weight equals to buoyancy. Now, if you slightly displace it by a distance x, then volume submerged is going to depend on this area. This area is pi r square, and extra volume submerged will be pi r square times of x. Extra volume submerged is this much. So, extra buoyancy will be density of the liquid into extra volume submerged into g. Now, that extra force should be equals to mass times of acceleration. So, that looks like SHM equation, and you can calculate the time period. The same thing goes for the everything. Here area is same everywhere, but here if this is pi r square, then this is going to be pi r square by 16. So, again when you press it by distance x, then it is going to be pi in this area into x. This area into x is the extra volume submerged, density of the liquid into extra volume submerged into g, that will be buoyancy. Buoyancy equals to mass times of acceleration, and you can get the density by making net weight equals to buoyancy. The same way here, if you press it slightly, then it is going to be this area, which is pi r square times of x is the extra volume. Instead of r, I am writing h because you can see radius was given h. Pi h square into x is the extra volume submerged, density of the liquid into extra volume submerged into g equals to mass times of acceleration. The same idea goes here, density of the liquid into extra volume submerged into g equals to mass times of acceleration. I mean, they have given the, I think the answer lies in the paragraph itself. The dark lines in the solar spectrum are due to absorption of corresponding wavelengths by outer layers of the sun. So, you can read it, the answer lies in itself. 2 moles of an ideal monoatomic gas, degrees of freedom were 3. And so, TV square is constant, BC process here, TV square is constant. And they were asking A to B, B to C, C to A, and cyclic process, what is going to happen. So, first of all, TV square is constant, T I can write it as PV by NR. So, I can say PV cube is some other constant. So, we should, I always write in terms of PV power x, so that it looks like polytropic process, easy to do the calculations. Then going back to this, I will be trying to adjust things for V naught and T naught if I take the pressure as P naught. Now, here at constant temperature, volume is becoming 8 times, so pressure will become 1 by 8 times. Now, this is VT graph is passing through origin, so that is constant pressure. So, this pressure entirely will be P naught. Then if I talk about A to B, it is constant pressure process, constant pressure process. In any process, delta U is N CV delta T is 900. Work done, you can say area under the graph, or P dV integral is going to be P delta V, where P is constant. So P delta V, volume difference is 3 V naught, and P naught V naught is N naught T naught according to our assumption. Then you will be getting 800, and when you add them, you will be getting Q. So that's how constant pressure process. Now this one is going to be constant temperature, so delta U is 0. Work done is going to be nRT log V2 by V1. It is going to be negative value. This plus this is going to be Q. Now similarly for this process, delta U is NCV delta T. Delta T is final temperature minus initial temperature. Now work done is going to be minus nR delta T by x minus 1, where x is this thing, right? Minus nR delta T by x minus 1, or you can integrate also. So once you get this, adding these two, you will be getting the value of Q. Now that itself says the answer. Now if you want to find the cyclic, for the cyclic process, delta U will be summation of all these, which is going to be 0 anyway. Now work done also, you can add them. Now this plus this is going to be Q, or you can add all the Q values, right? So that will give you the required answer. So going to the next question, they have given some graphs, and they were asking, in cyclic process, delta Q for BC. For BC process, delta Q must be positive. BC process, it is P by V versus T is passing through origin. I can say slope of this line, if I want to find, I can take any coordinate and I can say y coordinate by x coordinate is constant. And by using ideal gas law, then you can write T as PV by NR. From here you can see P and P will go. So V square is some constant. So it is constant volume process. Constant volume process, work done is going to be 0, and temperature is reducing. So NCV delta T will be negative. Summation of these two is going to be negative. In this case, it is constant temperature process. So delta U is 0. From here to here, density is reducing. Density is mass by volume. If density is reducing, volume is increasing. So work done is going to be positive. This plus this is going to be positive. And in the third case, it was U by V, and they said Ci is rectangle hyperbola, that is this into this is constant. So U is constant, internal energy is constant, temperature is constant. So if I call this internal energy as U naught, this entire thing will be U naught. Now from here to here, volume is increasing, but U by V is constant. If volume is increasing, U should be increasing. So internal energy here is more than this, greater than U naught. From here to here, it is decreasing, right? So from here to here, delta U is negative, and from here to here, volume is increasing. So work done is positive. And I think anyway we need must be positive, so we can't talk about the values of their summation. Now in the next case, again if I assign temperature T naught here, at constant volume pressure is becoming twice, so temperature will be becoming twice. At constant pressure volume is becoming twice, so temperature will be becoming twice. So from here to here, initial temperature and final temperature were same. In between we don't really care. Initial temperature and final temperature is same. So from here to here, delta U is 0. From here to here, volume is increasing, so work done is going to be positive. Summation of this is going to be positive. So I think two options may match. We need to calculate what is the force on the upper half. So we have already decided lot many times. It's always better to talk about a scenario where there is only liquid. Now force exerted on this part is nothing but force exerted on this part. Force exerted on this part by the upper liquid, or I can say that is equals to force exerted by this one, by this thing on the upper liquid. So when you draw the free body diagram of this, and when you see what is the force, this pressure force and weight is balanced by this force. Pressure force plus weight is balanced. So that is correct. The force on this curved part is this much. Similarly, if you want to talk about this part, I can say force on this curved part and this curved part will be same. So, I will be drawing the free body diagram of this, and I can say this pressure force plus this weight is balanced by force on this curved part, this pressure force plus this weight, right. Then rest of the options you should be able to understand easily. String is tight, the meaning is buoyancy force is more than weight, more than weight. So, from there you will be getting remaining options. Force of buoyancy on the sphere minus weight is certainly positive. Yes, that is correct. So, R, S, T are easy options, you can do by yourself. Now, in this case, basically the force on this y surface, this flat surface and this flat surface will be getting cancelled. There will be force on the rim, that is going to create the buoyancy. So, force on the rim is going to be buoyancy density of the liquid into volume into G, which does not match with option P. Now, if you want to find force on this flat surface, that is going to be pressure at the centroid times of area. Pressure at the centroid times of area, centroid is at a distance 5r by 3, 2r by 3 plus r. Now, if you want to find the proof of centroid, pressure at the centroid, like we would have done in the class, for rectangle it is average pressure into area. Similarly, if any random shape if you take, the integration is going to look like center of mass integration, like y dm integration. Y dm integration is going to be m into y coordinate of center of mass, y dA integration is going to be area into y coordinate of center of mass. So, that is pressure at the centroid into area. For rectangle also I can say pressure at the centroid into area, because average pressure or pressure at the centroid both turns out to be same. So, average pressure into area, R, S, T you can do them easily, because as the tension is there, weight should be more than buoyancy. Now, in this particular case net force is 0 on this. If you want to find the force here, then it is going to be pressure there times of area there. Pressure there depends on height, pressure there times of this area, which is option wrong. Now, similarly, what the rest of the thing, it is going to be pressure there into the rest of the area. Now, they said it is going upwards, so the meaning is buoyancy is greater than weight and density of the liquid is more. Now, in this case they were asking about force on this part. Force on this part will be pressure there into area there, pressure there will be P naught plus rho g into r by 3 into that area. That area is going to depend on 2r, pi into 2r whole square, right. Now, similarly they were asking about y which is in contact with the liquid. So, the area in contact with the liquid is only pi r square, that is pi into 4r square minus pi into 3r square. So, only pi r square is the area here. So, pressure there is going to be P naught plus rho g into 5r by 3, right. So, this is the force here, but if I want to talk about the total buoyancy force, which includes this pressure force also, that I included here. I mean, so the force from here and from here, the force on this part which is in liquid is this much, the force on this part because of the air is this much. This is the force on the top part. Now, you should be able to see P naught into 4 pi r square, P naught into 4 pi r square will be getting cancelled. Here you are getting 4 by 3, here you are getting 5 by 3. So, net buoyancy is in the upward direction, weight is in the downward direction. Now, and they said it is in contact, so the meaning is weight should be more than buoyancy, then normal will be coming into picture. Weight is more than buoyancy. From there you will be getting the relation between sigma and rho is sigma is greater than or equals to rho by 16. That does not convey any information about whether it is greater or lesser. Possibilities will be there, because sigma greater than rho by 16 says sigma can be greater than rho also. Now, sigma greater than or equals to rho by 16 will say sigma is somewhere between rho by 16 and rho also. So, any possibility is there. During melting of slab of ice melts and becomes water and volume is going to reduce. Density of the ice is less, volume of the ice will be more. So, when ice melts, volume will become less. The meaning is surrounding atmosphere is doing work on the ice water system. Positive work is done on the ice water by atmosphere. Atmosphere is compressing it. Now, by energy conservation you can say, if someone is doing work, on ice water system, then internal energy should increase, right, by energy conservation. Now, in physics we will write energy conservation like this: heat given to the gas, some of it will be converted as internal energy, some of it will be utilized to do work by the gas. Or in chemistry, I think you people will be writing heat given to the gas and work done on the gas will be changing the internal energy. In this particular case, work is done on the system, so change in internal energy, that is bond breaking and all, we don't really bother. Two identical objects A and B are at temperatures Ta and Tb. Ta is greater than T and Tb is smaller. Both objects are placed in room in perfectly absorbing walls maintained at temperature T. There is this room which is maintained at temperature T. This is higher, this is lower. So eventually they will come to thermal equilibrium and this temperature will be T, and so the meaning is this temperature will reduce, this temperature will increase. The meaning is effectively it is losing energy, effectively it is gaining energy. So it will be emitting E sigma A Tb power 4, it will be receiving something. This will be emitting E sigma A T power 4 and it will be receiving something. So A only emits radiation? No, A will always emit and absorb. This is also wrong. A loses more heat by radiation than it absorbs. That's correct. That's the reason its temperature is reducing. B absorbs more radiation than it emits. That's correct. So they attain temperature T. Both A and B only absorbs radiation. That is never correct. Each object continues to emit and absorb radiation even after attaining temperature T. Even after attaining temperature T, they will be emitting energy, but they will be receiving the same amount of energy back. A particle of mass m 3 kg is constrained to move along a straight line. A and B are two fixed points on the line at a separation of, this was 1 meter. When the particle is at some point P between A and B, it is acted upon by two forces given by this much, where magnitudes of PA bar and PV bar in meter. At time t equals to 0, the particle is projected from A towards B with particular speed. Then they were asking when it is going to reach B and oscillation energy. So from there you should have understood it should be some kind of SHM thing. So let me say that location is x. If this location is x at a distance x, total length is 1. So this is going to be 1 minus x, and according to the given information in the question, force is 200 times of PA in the direction of PA bar. So force is in this direction. So when the particle went from here to here, force is in this direction. Now similarly, this is 100 PB bar, 100 PB bar, 100 into 1 minus x in the positive direction. So that is the net force equals to mass times of acceleration. Now you should be able to see this looks like SHM format. To make you understand it, we will be taking minus 300 common, and x double dash we can write as x minus 1 by 3 whole double dash. So that if you look at this one like some term, some box, sorry, this has to be, no double dash is there, it is only x minus 1 by 3. Anyway, so box double dash equals to some negative thing with box. So that is like SHM thing with equilibrium position x equals to 1 by 3. With equilibrium position x equals to 1 by 3, so somewhere here equilibrium position is this much, and it is like spring constant. This is like spring constant and this is mass. So I can say initial kinetic energy is half mv square, and k value is like this, like spring constant value. If I compare half k into x square, half k into x square, that is from mean position it is at a distance 1 by 3. We understood, right? Mean position is at a distance 1 by 3. So from here it is at a distance 1 by 3. So from there you will be getting energy of the oscillation, which should be equals to half k into a square. From there you will be getting amplitude is 2 by 3. So if mean position is here, this is 1 by 3, this is 1 by 3, and amplitude is 2 by 3. So this is the other extreme. If this is the mean position 1 by 3, from here amplitude is 2 by 3, total distance is 1. So this is going to take t by 4. From mean position to extreme it will take t by 4. Half of the amplitude it will take t by 12. That you will be knowing. Even if you don't know, you can calculate it. half of the amplitude and amplitude. So it is going to take that much time to reach from the given location to B. In the figure shown, a rod is kept on floor and applied some forces. If you notice, the net force is 0, 2F, F and 3F. So everything is in equilibrium. Now if you try to understand the restoring force here, you can either draw free body diagram of this part or the rest. From there you will understand, as this is in equilibrium and this side force is 2F, restoring force should be 2F. So I can convince you, no matter which location I talk about, the restoring force will be 2F. In the similar fashion, if I want to find the restoring force here, if you draw this free body diagram, the restoring force here will be 3F. Anywhere is going to be 3F. So once I understand that, I can say, if you take this guy and apply 2F and 2F here, he doesn't know the difference between this scenario to this scenario, because restoring force here and here everywhere is 2F. Similarly, if you take this guy and apply 3F and 3F, he doesn't know the difference between these two, because restoring force everywhere is 3F. In this case, you can find the extension easily. In this case also, you can find the extension easily. Sum of them is going to be the total extension. And stress at P and Q are not equal, because here the restoring force is 2F, here the restoring force is 3F. And the ratio also you can find easily. So going to the next question. In Searle's experiment, after every step of loading, why should we wait for 2 minutes? So basically they were saying, after loading we don't immediately take the reading, we wait for some time. So now mostly you will be expecting why we wait is vertical oscillations, we are waiting for it to settle down. Settling down helps us to understand the change in length, and we will be waiting for some more time, so that like temperature effects also can be negligible. We allow it to settle down. Change in radius, even if we settle down, change in radius will be there. So change in radius is always there. A 50 kg ball is attached to one end of 1 meter cord that has mass 0.1 kg, which is very small when compared to 50 kg. The other end of the cord is attached to the ring that can slide down frictionless horizontal shaft, as shown in the diagram. A horizontal blow is delivered to the cord and excites the fundamental vibration with a maximum transverse velocity of 15 meters per second. Assume the ball remains essentially stationary as the cord vibrates. Then fundamental mode, amplitude and equation and time period of pendulum. So V equals to root of T by mu. Tension you can get 50 into G. Mu value was given 0.1 kg, and where this length is 1 meter. We can easily say option C is correct if you take this is x equals to 0. At x equals to 0, and this is going to be node and this is going to be antinode, that is free to move, right? So when x is 0, it should be 0, and when x is L, the angle should be pi by 2, because the first antinode. So when you substitute in the equation, when x equals to L, you will be getting a sin pi by 2. So that equation is going to represent fundamental. When x equals to 0, it should be 0. When x equals to L, it should be the first antinode, because they said fundamental, right? This is antinode and this is node. And velocity you can get then lambda by 4, as it is fundamental, this is node and this is antinode, that is lambda by 4 equals to 1, lambda equals to 4. If you know velocity and lambda, you can find the frequency. And maximum velocity of the particle is a into omega. Omega value is 2 pi f. From there you will be getting the amplitude. And I think the last question it is entirely different. It seems if this was an SHM thing, if you leave it and it is going to perform SHM, what is its time period? I think that is how option D will be matching. Equation of travelling wave is given, then which of the following statements were correct? And you people will be aware of, this is travelling in a positive x-axis direction. Omega value you know, maximum acceleration is going to be omega square times of a. This was in millimeters, so 3 into 10 power minus 3 I have written. Now maximum velocity is a omega, and speed of the wave, it was lambda by t, or v. It was written wrong, but it was substituted correct, right? Then going back to reflected wave part, and I am going to attach the derivation, which you will be knowing. So it is going to look like reflected waves equation is going to look like this thing into incident waves thing, where wherever x is there, whatever happens at x coordinate of reflected wave will depend on whatever is happening at negative x coordinate of the wave. There is an explanation also here, interpretation. In this particular case, Vt is going to be 0, so this is going to be -1. This is going to be -1. So when I plug in back, so I will be getting -1 times of this entire thing, but with a minus extra here over the x. So option C is wrong because there is an extra minus sign needed here. And see, for any, if V2 is 0, if this is the incident wave, this is going to be reflected, they were telling. So mathematically whatever we were telling is, for every incident wave or whatever happens at, I mean this thing, sorry, it will be, this thing will be this thing, assume the same shape I am drawing here, it is whatever. So whatever happens at x coordinate here, the similar thing will happen at negative x, or whatever happens at this x coordinate will happen at this negative x coordinate. Now this is mathematically going to go this way. So mathematically whatever happens at positive x will happen for reflected ray at negative x, and this is physically present now, that will be only mathematically present, right? That is the rough idea. Gaseous products of burning are released into atmosphere of temperature Ta through high chimney of cross section area A and height h as shown in the figure. The solid matter is burnt in the furnace which is at temperature Ts due to burning smoke. Okay, so you can read the stuff. So basically it has something to do with Bernoullis. So they were saying like in colder region, if the height is 100 meters, then what is the height needed in hotter regions? So let me talk about the information. They said the density of the air and temperature of the air here. So if the pressure here is P0, then when you go up, pressure decreases, because they said that is how you need to take it. They were saying the same thing here in 4th point. The pressure of the air changes with height according to hydrostatic law. If the pressure here is P0, pressure here will be less. How much less? Rho gh. Now, yeah, so the pressure here is P0, so the pressure here also P0, it is air vent. The pressure here will be this much. So if you apply Bernoullis between these two, pressure here plus rho gh, if you take this height reference as 0, and its velocity is negligible, they said in the question. So half rho v square term also is 0. Now pressure here is this much and height difference is there, so rho gh, but understand this rho is smoke because you are using Bernoullis. This thing we borrowed from here, and half rho v square, v is q by a, half rho v square, and these two should be equal. When you solve for it, you will be getting this kind of expression. Now this is our constants. Now we need to write this in terms of temperature. Rho a is the density here, everywhere it is same. So rho a is the density outside and rho s is the density of the smoke inside, where temperature is this thing, Ta and Ts, right? So if you use PV equals 10 RT, you will understand rho is inversely proportional to T. Rho is inversely proportional to T, you will be getting. Once you get rho is inversely proportional to T, then you can substitute the values and you can get the answer, right? Going to the next question. This question is majorly understanding the radial flow based on Poiseuille's equation. An ideal fluid flows through a pipe of circular cross section. I think similar question is there in your revision material, but the flow was not given in a right way. They said assume it is linearly varying, but it won't be linear. So if the rate of flow is same, then what is the maximum speed of the viscous liquid thing? So if there is a pipe, then speed will be more at the center and near the whatever pipe borders, the speed will be less, and that speed profile is going to be like this. If you want to understand the speed profile, you should be understanding Poiseuille's equation. There will be a video on this in your doubt clearance folder. I think in the class also you would have learnt. Velocity profile will be varying with r square, distance square. Volume flow rate is going to be area times of velocity. Area of this is 2 pi x dx and its velocity profile is this much. When you integrate, you will be getting the rate of flow that should be equals to pi r square times of 4 that was given in the question. Now, the only important thing in the question is understanding this profile. Then it's only about substituting the values. That profile you can get easily by drawing the free body diagram of this and making net force 0. Pressure difference times of area will be equals to the viscous force. Consider 3 rods of length L1, L2, L3 joined in series. Each has some cross section area with Young's modulus y, 2y, 3y respectively, and thermal coefficients of linear expansion are alpha, 2 alpha and 3 alpha respectively. They are placed between two rigid fixed walls. The temperature of the whole system is increased and it is found that the length of the middle rod does not change with temperature rise. Find the value of L1 by L3. See, basically these are the 3 rods. When you take them and heat them, each one is going to increase its length. It is going to become L1 into 1 plus alpha delta t. I can write as e power alpha delta t. Approximately it is going to be 1 plus alpha delta t. So, its length will increase, its length will increase, its length will increase naturally. These are their natural lengths after heating. There is no stress right now. But what we are doing now, something when you put them and when you heat them, they are saying its length is going to remain same. So, which natural length is this much is going to become exactly this much. Now, in this process, according to my figure drawing, I assumed this is extending further. This is extending further and this is compressing further. This is the natural length, but it became this much. This is the natural length, but it became this much. And this is the natural length, but it became this much length, they said. So, I can say when compared to this length, it increased by x, and when compared to this length, it decreased by x. So, this is the natural length of the green guy, but it became this much. So, I can find stress. Stress is going to be Young's modulus times of change in length by original length. Change in length is natural length at this temperature by this new length. By original length is this much natural length. So, stress in green guy is this much. Similarly, stress in the yellow guy will be y times of his change in length. This is the natural length, this is the new length by natural length. Again, for this guy natural length is this much, new length is this much. But approximately these values will be L1, L2 and L3, right. So, yeah, it is only about solving. Once you reach here, you can see x by L1, x by L3 are there and alpha delta t. So, you can find x by L1 in terms of alpha delta t, x by L3 in terms of alpha delta t. Then you can take the ratio. 4 identical massless springs of 2 massless springs, 2 massless pulleys. So, basically it is going to perform SHM. You need to calculate what is the time period. So, when you disturb it and when it is oscillating, let me say it went down by distance x. If it went down by distance x, the spring is going to compress by x. Now, there will be elongations in this spring. So, I am calling this as x1 elongation, x2 elongation, x3 elongation. Now, if I look at this pulley, that is massless, so net force should be 0. So, this force kx1 should be balanced by kx2 and kx2. From there, I will be getting the relation between x1 and x2. Similarly, kx3 should be balancing kx2. From there, I will be getting the relation. Now, understanding how this displacement is related to this. Now, suppose let me say only x1 is happening. This spring is not elongating, this spring is not elongating. If only this spring elongates, this pulley goes down by x1, this part and this part, which is x1 and x1, 2x1 will disappear and this pulley is going to go down by 2x1. If this pulley goes down by 2x1, then 2x1 will disappear and this is going to go down by 4x1. So, if this alone expands, then this is going to go down by 4x1. Similarly, if this alone expands by x2, this x2 will disappear and this is going to go down by 2x2. If this alone expands by x3, then this is going to go down by x3, but all are happening. So, this is going to go down by 4x1, 2x2 and x3. Anyway, those are all secondary things. We will be writing F equals to mf for this guy. The force in when it goes down, the immediate contacts for this. So, this is going to pull it kx3, this is going to push it kx. net force equals to mass times of acceleration. Acceleration is double differentiation of his displacement. Now we need to write x3 as a function of x. For that we will take help of this and we will use these equations also. We will use these equations also. I am trying to find in x2 in terms of x, thereafter I can find x3 also, right, x3 in terms of x. Once I get x2 in terms of x, then I can get x3 in terms of x, then I can substitute it back and I will be getting the answer. It's a straightforward question. You write f equals to ma, then you write lot many equations so that it looks like SHM. So they have given some information. It's just that you will be drawing the free body diagram of some mass, and with the distance we will be assuming pressure will be increasing. If you are assuming it is decreasing, then you need to put a modulus with a negative sign and remove the modulus. That is going to be headache. Eventually mathematically it will turn out to be the same thing. So I am assuming with the distance pressure is increasing. So here the pressure force is P into A, here the pressure force is P plus dP into A, and its weight, and it is in equilibrium. So making net force 0, P into A will get cancelled. So dP into A plus this thing should be equals to 0. And then here there are 3 variables, you need to convert it into 2 variables. For that you will be taking help of PV equals to nRT. From there you will be getting P equals to rho RT by M, and temperature dependence on the distance was given. From here you can see there is a relation between P, rho and Z. Here also P, rho and Z were coming, so we can eliminate one variable. What is the variable I am eliminating? I am writing rho in terms of P, rho in terms of P, this rho in terms of this P. Yeah, this P I am taking to the left hand side, then you can get an integration, and Z equals to 0, pressure is P naught. At any Z, the pressure was this value given in the question, and they asked you to find the value of alpha. By using this information, I have written P M by RT naught. M by RT naught is rho naught by P naught. M by RT naught is P naught by rho naught. Then you have to integrate and you have to substitute the limits. Then it's a straightforward substitution. Now the only thing with the previous question is draw the free body diagram. It is found that the spectral line of certain star periodically becomes a doublet, indicating that the radiation actually comes from stars revolving about their center of mass. Assuming the masses to be equal, find the distance between them if the maximum splitting of the spectral lines is this much, and it happens after every 30 days. Yeah, when the star is rotated, when the binary star is rotating about their center of mass, when it is at this scenario, this guy will be feeling this is very far distant. So he will be feeling this velocity is along the line joining, this velocity is away from the line joining. So when the velocity of the source is away from the line joining, when it is making a wave, the wavelength is going to become more. When it is coming towards, then wavelength is going to become less. So the difference in the wavelength we will be measuring is this much. By actual wavelength is c into t naught, where c is the speed of the light and v is the velocity of star. So we need to calculate this value. Okay, so v is r omega, but they are asking you to calculate 2r. 2r is going to be delta lambda by lambda times of c by omega. C by omega. How will we find omega? They said this will happen after some time. So again this is going to happen when this goes here and this goes here. So when this rotates by 180 degrees. So omega into that given time should be equals to 180 degrees. Omega into that given time should be equals to 180 degrees. So omega is pi by that given time. Then it's the values you have to substitute. The time is 30 days, 30 into 24 hours into 60 minutes into 60 seconds thing, right? In resonance column apparatus, first resonance is obtained when the water filling beaker of cylindrical shape is just empty as shown. The water filling beaker is lowered down, and it is seen that the second resonance is obtained when the beaker is filled up to the brim. So when it is lowered down, extra volume of liquid is going to come from here. Some liquid will disappear here and will come here. And so how much volume is going to be filled? How much volume is going to be filled? Pi 4 square into 10. From where? From here it disappeared. Pi 2 square into x. So the length of water disappeared here is 40 centimeter or 0.4 meter. 0.4 meter. Now from there you should be understanding. If I try to draw the pressure graph, pressure is going to be minima here, maxima here. So you will be getting something like we don't know which kind of standing wave was that. So something like this. Then when the liquid level is reduced by 0.4 meter, then again you will be hearing a loud sound. So this gap is going to be lambda by 2. The distance between two consecutive loud sounds, that thing is going to be lambda by 2. So lambda by 2 is going to be 0.4. So lambda is going to be 0.8. Right? And they were asking, you need to write, that is 8 by 10. Right? Thank you.